Resources such as sunlight, water, and nutrients are vital to aquatic and terrestrial plants alike. Oceans, although they receive the same amount of sunlight as land areas and have greater access to water, have lower average photosynthetic productivity because of nutrient limitations. Some places, specifically the eastern equatorial Pacific, northeastern subarctic Pacific, and southern ocean, have relatively high concentrations of most nutrients, yet support only low densities of phytoplankton, free-floating plants. Addition of iron to these waters generates massive phytoplankton blooms. These phytoplankton blooms convert additional atmospheric carbon dioxide into organic carbon, some of which sinks into the deep blue sea, where turnover back to the atmosphere may take millennia. The potential of this approach for greenhouse gas mitigation depends on how much carbon is sequestered per iron applied. Large-scale experiments in the Southern Ocean found this ratio is only about 1% of that predicted from laboratory studies. Apparently, phytoplankton cannot absorb most of the iron added to the ocean. Physical reactions in the oceans remove a substantial portion of the iron, and only 5 to 10% of the organic carbon from phytoplankton photosynthesis exits surface waters because other organisms near the surface efficiently recycle it. Iron fertilization of oceans, therefore, is unlikely to make a significant dent in atmospheric carbon dioxide concentrations. The scale, complexity, cost, and uncertainty of geoengineering worry everyone. How can you engineer a system whose behavior you don't understand? Asked Ronald Prin, a climate scientist at MIT. All the geoengineers in this video segment consider their proposals to be the last resort. Actions to be taken only if abatement of greenhouse gases emissions fail to avert catastrophic climate change. Fortunately, as detailed in many of these videos, alternatives involving energy conservation are available. In summary, number 1, geoengineering approaches involve increasing Earth's albedo and fertilizing Earth's oceans. Number 2, methods to increase Earth's albedo include placing sunshades into orbit, releasing sulfur dioxide into the upper atmosphere, and seeding clouds. Number 3, the scale, complexity, cost, and uncertainty of geoengineering worry nearly everyone.